Hello students, I'm coming to you with the next video lecture on Rubin and Babbie chapter 15. So let's go ahead and get started. So we're continuing on with our discussion of survey research. And as I mentioned in the last video lecture, survey research is most appropriate for use with large sources of data. And so one topic that is very closely linked to survey research is that of sampling. So we will be discussing sampling in this video lecture. I want to begin this discussion by talking about the relationship between survey research and sampling so that you can see how these two topics are interconnected. So first, survey research makes studying large populations feasible, as I just mentioned. In survey research, sampling is employed in order to select a subset of individuals from a larger target population. And it is through probability sampling in particular that researchers attempt to estimate the characteristics of the whole population. And the ultimate goal is for samples to reflect the target population from which they are drawn as much as possible. So the one thing to keep in mind here is that in survey research, we are typically not studying entire target populations. Rather, we are drawing a sample from the larger target population to study. The other thing to keep in mind that we will discuss later on in this lecture is that how we sample matters. And there are certain kinds of sampling techniques that allow for achieving this representative sample that is a reflection of the larger target population, because that's the ultimate goal. We want to be able to mirror the target population as much as possible. And there are certain types of sampling techniques that make something like that possible. So let's talk about the purpose of sampling. So one of the major reasons for sampling is that, as I mentioned, there are times when the whole group is so large that it is impossible to study every single individual case that makes up that population. So sampling allows the researcher to study a workable number of cases from the large group in order to derive findings that ideally can be generalized back to the larger target population. Our ability to make generalizations depends heavily on how we sample. And so that is what I mentioned before. It's not just about sampling, but it's also about how we sample. Samples must be representative of the target population in order to make accurate generalizations. So if our goal is to generalize, then we have to be concerned about how we go about sampling. So we will talk about that as we move forward. So a representative sample is one that accurately reflects the characteristics of the target population. The sample is considered to be a small reproduction of the larger population. And ideally, a representative sample should have all of the same characteristics as the target population. Representativeness of samples allows study conclusions to be legitimately generalized back to the population from which it was drawn. So in other words, we cannot claim representativeness if we do not use the sampling techniques that allow for achieving representativeness. And so we have to be very careful in the conclusions that we draw because it really all hinges on how we go about sampling or how we go about drawing our sample from the larger target population. As I mentioned, there are some sampling techniques that allow for legitimate generalization, and there are others that do not. And so it's important to understand the differences between the two. So there's this circular reasoning underlying the concept of probability sampling in particular. So the whole idea here is that because we cannot study larger, or typically cannot study larger target populations, we select a sample from the population. And ultimately, if we sample appropriately and we utilize probability sampling methods, then we are able to reasonably and legitimately make generalizations and conclusions that we are able to link back to the larger target population. So again, we generate a sample from the larger population in order to be able to make generalizations about the target population. But again, how we sample matters. The other thing that matters is sample size. Specifically, as we know, samples are just estimates of the larger target population from which they are drawn. However, samples that are smaller in size tend to be poor estimates of the larger population in comparison to larger sample sizes. So the general rule of thumb is the larger the sample, the better. So here's an illustration of this relationship between sample size and sampling error. So essentially, we see here that our smaller sample size of 5,000 has a much higher percentage of sampling error in comparison to our sample size of 30,000, which has a much smaller percentage of sampling error. So essentially, this illustration is showing this relationship between sample size and sampling error in that smaller sample sizes have a higher degree of sampling error in comparison to larger sample sizes, which tend to have a lower degree of sampling error. So this is something to keep in mind as well. Now let's talk about the difference between probability sampling and non-probability sampling methods. So we will begin by talking about probability sampling methods first. So what is probability sampling? So it is the idea that every case in the population is randomly selected and thus has an equal chance of being included in the sample. Probability sampling makes it possible to produce unbiased representative estimates of a population. So before we get into the specific types of probability sampling methods, these are three concepts that must be understood in order to further understand each type of probability sampling technique that we will discuss going forward. So first, a population refers to all possible cases of what you are studying or interested in. So this is the entire universe. This is every single individual or case that makes up your population of interest. A sample, as we've already learned, is a subset of the population, and it consists of one or more cases that we select or extract from the larger target population. And so we're adding to our understanding now this idea of a sampling frame. A sampling frame is a listing of all cases in a population. And so this is a very simple concept, really, that we're using, that we're referring to with this very fancy wording of sampling frame. So I really don't want to unnecessarily overcomplicate this concept. All a sampling frame is a listing of all cases in the population. So it's literally just a list of every single individual or person that makes up our target population. That is all a sampling frame is. So this is just a visual here to help further explain this relationship between population sampling and sampling frame. So ideally, what we want to study is the target population, okay? And a sampling frame is a listing of every single individual in our population. And so from this list, we are able to generate a sample, okay? And so this is what we actually study. Although ideally we want to study the target population, because it's often not feasible to do so, what we end up actually studying is our sample. Okay. And so from that sample, if we sample appropriately, we are able to draw inferences and conclusions that we can then generalize back to the larger target population. So our sampling frame here is just a list of our entire target population. And from this sampling frame, this is where we draw our actual sample. So we select individuals from our sampling frame to be included in our study. So this is just an example of a sampling frame. Let's just say this is a listing that I was able to draw hypothetically from the Garland School of Social Work. So the hypothetical example here is that I went to the admissions office in the Garland School and asked for an entire listing of every single BSW student in our school. Okay, so this would be our, this would in this case be my sampling frame. Okay, and this of course doesn't list every single student, but let's just say this is a partial list. And we will draw on this example here as we move forward in our discussion about each of the various different types of probability sampling methods. So the first type is simple random sampling. This is the simplest technique for drawing a probability sample. To select a simple random sample, you must first develop a complete sampling frame with all elements or cases in the population and assign a unique number to each case. So for example, as you saw on the previous slide, each case was numbered 1 to 16. Then we can use a computer-generated program or a random numbers generator to select elements or cases randomly until we reach our desired sample size. So here's an example. This is what our random numbers generator looks like. So if you were to navigate to the link from the previous slide that I just showed, this is our random numbers generator. And so our total population size is 16. So let's just say that our desired sample size is 8. So I can essentially put the minimum number here is 1 and the maximum is 16. And I can hit this button here if were actually in the site, I could hit this button here that says generate. And each time, and I can continue to click on this button and I can click on it a total of 8 times. And each time it would generate a different case number for me. Okay, and so these are all of the case numbers. I actually went through this exercise myself, and these are the case numbers that I was able to draw from this random numbers generator. So it selected for me case number 14, 4, 12, 10, 9, 3, and 8. Okay, so these 8 cases would be selected for inclusion in my study. And so the actual 8 cases here are these specific students. Okay, so this is an example of simple random sampling and how we would go about, or one of the ways in which we could go about generating this kind of sample. And this is just another visual here to help to get this point across in terms of this specific sampling technique. So in other words, we are just randomly selecting cases here. And we are selecting those cases that are generated by our random numbers generator. The second type of probability sampling method is referred to as systematic random sampling. And this involves selecting every case element or case listed in a sampling frame. You must first, in order to generate this type of sample, you must first develop a complete sampling frame with all elements or cases in the population and assign a unique number to each case. So again, we are assigning a number 1 through 16 to each case in our sampling frame. Then we select a random starting point, and it cannot be the first number on the list. And from this point, we proceed by selecting cases at a fixed periodic sampling interval that we refer to as K. So this can be every second case, every third case, every fifth case. So it is really up to us as the researcher to determine what K represents. So whether it's the fifth, sixth, seventh, whatever interval we will select, we just need to be sure that we're consistent throughout our selection of each case from our sampling frame. So for my fixed interval, I chose every second case. So as you see here, it's every second case that was selected. So each of these individuals would be selected for inclusion in my sample. And so this is just an example of how we go about generating a systematic random sample. And this is another visual here just to help further explain this concept. So in this visual, it's every third case, okay, that's being selected. So the next probability sampling technique is referred to as stratified random sampling. So simple random sampling as well as systematic random sampling assumes that the entire sample is homogeneous or has similar, the same or similar characteristics. However, stratified random sampling allows for extracting subgroups or dividing a population into homogeneous subpopulations that we call strata. Before beginning the sampling process and randomly selecting from within each strata. So each stratum or strata is considered an independent subpopulation from which a simple or systematic random sample can be drawn. So in other words, there may be instances as a researcher in which we may be interested in studying a particular phenomena based on race. And so it may be important for us to stratify our sample so that we can be intentional about ensuring that every single racial group is equally represented in our sample. Now, if we don't have any interest in studying any specific characteristics, then we may employ a simple or systematic random sample. But if we are interested in the characteristics of our sample in any way, whether it be race, let's just say it could also be age. Maybe we're studying a topic that is very important to be explored based upon the age of our participants. So we could stratify based on age. We could stratify based on income if that's of importance in our study. So it really depends on what characteristics are most important in your study. And we could go about stratifying our sample based on those characteristics. So the steps involved in generating a stratified random sample involve beginning with a sampling frame, of course, because we know that all of our probability sampling techniques rely on having access to a sampling frame. So once we have our sampling frame, we divide our list into strata by characteristics of interest. So in this case, for the example that we'll use for this, let's just say that we are interested in the class standing of our students. So we could stratify based on class standing. Once we have divided our list into strata, then we are ready to sample. And so what we would do is we could either utilize a simple random sampling technique where we utilize our random numbers generator to sample from within each strata, or we could utilize a systematic random sampling where we could choose every second or third or fourth or fifth case or some fixed interval that we would utilize in order to go about selecting from within each strata. So here's an example. So we could stratify our list of BSW students by their class standing. Okay, so we would place all sophomores into one group, all juniors into another, and all seniors into another. And we would sample from within each of these strata. And again, we could utilize a simple random sampling method, or we could utilize a systematic random sampling method. It doesn't really matter. The most important thing is that we stratify. So we get all of our cases into their appropriate strata, and then we can select any other probability sampling technique in order to sample from within each of our subgroups. And so the other thing to keep in mind about stratified sampling methods is that there are two different types. There's proportionate stratified sampling, and then there is also disproportionate stratified sampling. So proportionate stratified sampling is a technique or method in which the size of the sample taken from each stratum is precisely proportionate to its presence in the larger target population. This method is utilized to make accurate comparisons among groups. So for example, keeping with our example of BSW students in the Garland School, if they're this is hypothetically their proportion within the larger population. Okay, so if seniors represented 20%, juniors 20%, sophomores 25%, and freshmen 35%, this makes up a total of 100% of the population. And so in turn, if we wanted to generate a proportionate stratified sample, we would need to sample from within each stratum according to each group's representation in the larger population. So in this case, if our total sample size were 200, then that would mean that we would need 40 seniors, 40 juniors, 50 sophomores, and 70 freshmen. And by comparison, we have disproportionate stratified sampling. This is a technique or method in which the sample size of the stratum is not proportionate to its size in the population. While this method does not necessarily generate a proportionate sample, it can still be helpful in making comparisons among subgroups. So in this particular case, we would completely bypass the proportionality of each group within the larger target population. Let's just say we don't care about the proportionality in this case. What may be most important for us is that we have an equal number of individuals in each group. So in this case, we're completely ignoring this idea of proportionality, and we are simply seeking to evenly distribute each of our cases into each stratum. This would be more of a disproportionate stratified sampling approach. And so I want to take a moment before we get into non-probability sampling methods in order to connect a few dots and to make some distinctions between some of the concepts that we have learned about thus far that might be sort of connected to some of the things that we've talked about with regard to sampling. So the first distinction that I want to make is regarding the difference between random sampling and random assignment. So random sampling is used in survey research designs, and it is the random selection of a sample drawn from a target population. And this is by contrast to the idea of random assignment. So we've also talked about random assignment, but we've talked about it with regard to experimental and quasi-experimental designs. And random assignment involves placing individuals into experimental and control or comparison groups. So there is a difference between random sampling and random assignment that I'd like for you to keep in mind. In addition, sampling bias is a problem in survey research, and it happens in the absence of random selection. So when we do not engage in probability sampling methods, this increases sampling bias, okay, because everyone does not have an equal chance or opportunity to be involved in our study. So in the absence of random selection, we increase our chances of sampling bias. And this is in contrast to selection bias. So selection bias is a problem in experimental and quasi-experimental research, and this happens in the absence of random assignment. So we talked about selection bias as a threat to internal validity. And that threat only happens when we fail to randomly assign. So I also would like for you to keep these two differences in mind. These are very subtle differences, but I want you to understand and be able to distinguish between these various different nuances and concepts. The bottom line here is that the absence of randomization produces bias. Whether we are talking about sampling bias or selection bias, there's this absence of random randomization that in turn leads to bias, whether it is sampling bias or selection bias. So what happens when there's no sampling frame? And again, as I just mentioned throughout our discussion on probability methods, being able to utilize a probability method in our research heavily relies on our ability to access a accurate sampling frame. However, there are instances in which we are unable to get access to this sampling frame that is so important for our ability to generate random samples. And this is very common in social work research. In fact, in my own work, because I was not able to get access to an accurate sampling frame, I had to rely on non-probability sampling methods. And so that is what we are going to talk about from this point forward. So what is a non-probability sampling method? This happens when every element or case in the population does not have an equal chance of being selected. Some may have no chance, while others may have a full probability of being selected for inclusion into the sample. And so, unfortunately, these methods tend to produce unrepresentative samples and are only appropriate if there is no intent to generalize or make inferences from a sample to a population. So, in other words, there are instances in our research, especially in social work research, where our intent is not to generalize. So it's not always the case that we intend to make generalizations and inferences from a sample to a population. There are instances in which we may not necessarily care about achieving a representative sample, and our goal is primarily to produce information that can be useful to us in our practice. And so in this case, utilizing a non-probability sampling method is totally acceptable. So I don't want you to think that non-probability sampling methods are bad per se. It's just that if our goal is to make generalizations, then it's very important that we make every effort that we can to produce a probability sampling method, or to produce a representative sample that can only be drawn from a probability sampling method. But I also want you to understand what your options are, as I always try to present options to you and give you sort of the best and worst case scenarios in all circumstances. And so again, if you ever find yourself in a situation where you're not able to achieve a sampling frame, or perhaps your goal is to not generalize and to only produce information that can be useful in your practice, then going the route of a non-probability sampling method is best. So let's look at types of non-probability sampling methods. So the first type is availability sampling, and this is also known as accidental or convenient sampling. This type of sampling method relies on selecting the most available subjects to constitute a sample, and it involves a researcher selecting whichever elements or cases in the population that are readily available. This method is appropriate when it is difficult or impossible to develop a complete sampling frame. So in other words, availability sampling, just as the idea suggests, it is a matter of sampling those individuals that happen to be readily available at the time of our study. And this is just a visual here that helps to reiterate this point. And so in this case, those who make up our convenience sample would be these individuals here. And as you can see, we have totally left these individuals out of our sample. So this is the reason why this kind of sampling method can be problematic in terms of making generalizations about a population. Is that we inadvertently leave out or exclude certain individuals in our population when we rely on convenient sampling methods. Snowball sampling is a technique that is used when we desire, when the desired sample is difficult to find or hard to reach. So some of the more hard to reach populations might be victims of child sexual abuse, or children diagnosed with AIDS, or in my case, for my work, non-resident fathers. perpetrators or even perpetrators of human trafficking or domestic violence. So the way in which this sampling technique works is that we start with a few cases and then we rely on referrals from those initial participants to generate additional cases. And so it allows the researcher to accomplish what is referred to as interactive sampling, or sampling of people who interact with one another. So as this visual suggests, we might inform one individual about our study, and then that individual refers 3 others about our study. And then several other individuals refer others. So it's really what the term suggests. It's a snowball kind of process. And then we have quota sampling. So this is the non-probability version of stratified sampling. And so like stratified sampling, the researcher divides the population into various categories. And from there, a quota is set on the number of cases selected for each category. Once the quota is reached for each category, there are no new cases placed within it. Researchers select cases into various categories based on an established quota. So this is in contrast to stratified sampling, which uses simple random sampling or systematic sampling to randomly select cases into each category or strata. So with quota sampling, we're not utilizing any kind of random sampling method in terms of placing individuals into each category. It's really about placing individuals into each category and stopping when our quota has been met. So there's no systematic randomization of placement in categories. It's just simply placing individuals within each category until we have met whatever our preset quota might be. So in other words, we see here, this is our population. And so we have placed 11 individuals that, let's just say hypothetically that these are our preset quotas. Okay, so we need 11 in this category, 16 in this category, 15 in this category, and 18 in this age category until we reach a sample size of 60. So we are not necessarily randomly selecting individuals into each age group. It's just a matter of placing individuals into each group until we have reached our quota. So there is no randomization involved. It's just placement of individuals into each group until the quota has been met. So now we're moving on to purposive sampling. So purposive sampling is also called judgmental sampling, selective sampling, or subjective sampling. So in purposive sampling, the researcher uses their judgment and prior knowledge in order to choose a sample that best serves the purposes and objectives of the study. The researcher intentionally chooses a sample that includes certain types of people because their presence helps to answer research questions. So in other words, in a nutshell, this type of sampling is where the researcher gets to be purposeful in how they go about selecting the individuals to take part in their study. They intentionally and purposefully select certain individuals that can provide certain accounts of experiences that help to answer their research questions. So we are not randomly selecting individuals, we are selecting individuals for a purpose. And so I like this image here because it kind of reminds me of the idea of cherry picking, right? So we are literally reaching out to our target population and hand picking each individual that we would like to take part in our study. That essentially encapsulates this idea of purposive sampling. So that is the end of this lecture. And so here again is my contact information as always. And I hope that this has been helpful, and I look forward to seeing you in the next class.